All right, so for our warm-up, and you can see here, you just want to make sure you're very careful with the instructions. This is just simplify. And again, when you have simplification instructions, no negatives as your exponents ever. That's a general rule. Other than that, radicals versus fraction exponents, either of those are acceptable, so I'm not going to get you for something like that. So if you see my answer has something different than yours, that's okay. However, if you do have a fraction in any of your answers, that fraction must be simplified, always. So let's take a look and see what these answers look like, shall we? I have no idea how, there it goes. Okay, so here we go. My answers. Okay, ask your questions. You can see here I'm fine with, for number 5, either having it in radical form or rational exponent form. Those are the same thing. Okay. Do you notice, first off, let me point out that this 4 is paired with that radical. It's not paired with the b. Is that okay? Okay, because I know the other class had some issues with the way I wrote it. Did everybody get those first 6 checked? Yes. So I'll go over questions. I just want to make sure that I can move this away. So check 1 through 6. Don't worry about 7 and 8 yet. We'll let you see that. I just want you to check it so I can move it away and start answering questions. Ooh, Craig, good call on the tea. That smells delicious. Oh. I'll give you props for that. Still see some up and down lookies. Give me 1 second. I see your hand, Kyle. Is it specifically about an answer or? Negative. That's okay. Yeah, that's like I said. And I know you guys were looking from far away, and those little things can sometimes be very easy to miss. Okay. So I heard my first question was on number 2. Is that correct? And I heard 5. Okay. So for problem number 2, we had 64, a to the 8, b to the 4th, all to the 1/4 power. Now everybody has different ways they deal with these larger numbers. I know where my mistakes are. I do much better with the variables because I make simple computational mistakes sometimes. So what I do is I look at 64. I know that's a power of 2. So 64 is 2, 4, 8, 16, 32, 64. So that's 2 to the 6th. And there are a couple of different ways that you can do this. You can do this as multiplication or a radical. Both of those mean the same thing. If you did that as a fraction, you would have had 2 to the 3/2 as part of your answer, which is perfectly fine. I just was thinking about it in this way. I said 4 goes into 6 how many times? Once. With how many left over? Oh, wait, no. Yeah, oh, so that should have been 4. Is that where my only mistake was? Number 6 should have been 4. No, this is 2. The inside's 4. Thank you. I saw 2. I said 4. Jiminy flippin' crickets. And actually, if we think about that 2 to the 3/2, when we have a 4 underneath, that does simplify again, which makes it very hard to kind of understand looking at it this way. But the 4th root of 4 is actually the square root of 2. So I'm going, what? And that's because, if you look over here, this is the same thing as 2 root 2. If I were to write 3/2 as a fraction or mixed number, that would be 1 and 2. My Lord, me and my 2's today. 1.5. I don't think I'm going to do that to you. I don't always pick those things, but I try to avoid stuff like that. So if that was to be on a test or quiz, it would be very minimal points. Okay. Okay, so are we okay with the fact that we're looking at the 64? That is the hard part. The reason why with the 4 root 4 is because that 4 came from saying 2 squared. Are you okay with that? 4 is 2 squared. If I write that as a fractional exponent, that's 2 over 4, which simplifies. And so this is like saying, leaving your answer as the 4th root of x to the 6th. You need to simplify that fraction. Okay? And again, I'm going to try to make sure that that's avoided because I know that that's just kind of cruel and unusual. But just so that you understand what the correct answer in that case is. Okay? And then I believe I heard number 5. Yes, sir? Oh. I'm sorry? Okay. So we've talked about the 64, which you can't see that I'm pointing to. Does that make sense? Are you okay with the 64? Oh. Okay, so are you talking about number 5 or are you talking about number 2? Okay, sorry. I thought we were still looking at number 2. I was like, all right. So number 5, switching gears, said 4n squared over 16 n to the 1/2. Well, I'm really hoping, why do I keep making that go down? Hoping that you guys all look at this and go, oh, I know that one. What is 4 over 16? 1/4. So that means the 4 would be in the denominator, and I got to bury that pen anyways. 4 is in the denominator, and then I have this n squared and n to the 1/2. To me, the easiest way to think about this is when I have same bases, something on top, something on bottom, what is my general rule for those? Subtract it. Craig, can you put your phone away? Subtract it. So this is going to be n to the 2 minus 1/2 over 4. So far, are you okay with what I've done there? It's not finished. I'm just saying, because if I had n to the 5th over n to the 3rd, you do 5 minus 3. This just happens to be a 2 and a 1/2. So I can do it this way. And 2 minus 1/2 is 3/2. Is everybody okay with what I've talked about so far? And you can either write it like that, or 3/2 as a mixed number is 1.5, or you can say 2 goes into 3 once with 1 left over. All of those are equivalent. If you didn't like that, and you had the n squared over 4, n to the 1/2 is the square root of n, you could have rationalized and then simplified. Massive paper cut, owie. It's the same thing. Yes, ma'am. Okay, so 3/2. Would you agree with me that that is 1.5? So that means that's n to the 1 and n to the 1/2 power, because those guys are added. What's a 1/2 power? Another way of writing that. So that's the n square root of n. No. For this guy, this does not fall under the write it as a fractional exponent or write write it in terms of rationals. This was just simplify. I would have been happy with this answer or that answer. Okay? If I say, like in your instructions on this one, if I say rational exponents, it must be that form. If I say express it as a radical, it must be that form. Okay? And if you didn't like to go directly from here to here, you can think about that as the square root of n to the third. 2 goes into 3 once with 1 left over. There are a lot of different ways that you can put together these exponential rules. It all just depends upon what are you seeing at that time. Okay? Yeah? 3. 3 is deceptively easy. Deceptive because it looks like it's going to be hard. And you have 21 to the 1/2. 3 doesn't have a square root. 21 is 7 times 3. It doesn't have a square root. But because these both are to the same power, this is like saying 3 times 21 to the 1/2. Are you okay with these two are equal? Because this is if I were to bring that exponent in. What is 3 times 21? 63. Or we can think about that as the square root of 63. That's okay. It happens. Just want to make sure you understand. Oh, I really gave myself a massive paper cut. Fudge. Ow. All right, let's take a look at the other answers. Yeah. So for number 6, it's just, do we have any exponents outside these parentheses? So I don't really need the parentheses. 5 times 3 is 15. That's that. And when I combine my x's, x to the 1/2 and x to the 3/2, I add those exponents. That's 4/2, which is 2. And then 3/4 plus 1/4 is 1. Okay? I know. I'm special today. I'm special every day, let's be honest. Yeah, what I'm doing here is you can have, if you have the C on the outside, and I just want you to know that either one of those are acceptable to me. Okay, if you put it all under one radical, then that C would be to the 30. I actually prefer writing it this way. And I get a little frustrated when people write it that way. Sometimes, if it's a multiple choice question, those were the ways your answers were given to you, you'd need to be able to recognize that. Yes, sir. Mm-hmm. Oh, thank you for catching that. That should be 10, z to the 10th. Good job. Doesn't it feel good to catch a mistake your teacher made? Yes. I see some funky looking faces. I know. Exponents are tedious. Yes, ma'am. Give me a problem so I know what we're looking at.
For instance, if it says like evaluate, what's the difference between evaluate the expression and simplify?
It's the same thing. Evaluate is another way of saying find out what it's equal to. Simplify is also find out what it's equal to, but simplify is specifically talking about in as small terms as humanly possible. Eden, keep thinking you're still over. Did you ever sit over on this side? Why do I think that? Oh, paper cut. They're all just like words that mean really the same thing. Uh-huh. Like number 10, is that what we're talking about? Okay. I prefer to leave it out like that. I just prefer to do it that way. But like I'm saying, if it's a multiple choice, I'd want you to understand that if your answer, everything had to be under the radical for a multiple choice question, what you would expect to see with that number. Okay? I think it's weird too, but I just want to make sure you've seen it. Ooh. Hey, anybody else? So yes. Oh my goodness. Okay, 4. Might be an important question. I don't know, I'm just saying. Just saying. I really hate that saying. Really irritates me, and yet I still say it. We have 2 to the negative 1 plus 2 to the negative 2, all to the negative 2. You can do any of your exponent rules in any order that you'd like, but no matter what, you must follow your order of operations, which is grouping symbols. Exponents and radicals are the same thing. It's just different ways of writing it. Multiplication, division are the same thing. Addition, subtraction are the same thing. And we always work from left to right. So even though I can do my exponent rules in any order that I want, that's only when I'm looking at just this step. I have to do this first. I must work inside the parentheses. So what is 2 to the negative 1? 1/2. 2 to the negative 2? And we know in order to add fractions, we need a common denominator. So when I add those, what will that be? 3/4. The negative says I would flip it over, do the reciprocal. And squared is 16/9. Okay? Completely different than if you were to distribute the negative 2 first. You can't distribute the negative 2 first because if you think about it, if I had a plus b squared, what does squared mean? What does it mean to square something? Multiply it by itself, which is going to give me a different answer than if I just pulled that exponent in. Okay, let's take a look at your homework. Specific questions on your homework. I will tell you that I'm a big dork and I can't follow my own instructions. 49 through 54 said use rational exponents, and I wrote them all as radicals. Hey, they both start with an R. Okay, yeah. Yep, nope, it was supposed to have been, for example, 49 should have been m to the third, n to the 1/2. 50 should have been y to the 3/2, x to the 1/2, y to the 3/2. 51 would have been 2x, y to the second, which is same. 52 is 17x squared y z to the 12/7. 53 would have been a squared b to the 2/5. 54 would have been 60 r to the 10th, s to the 7th, t to the 27/8. Huh? Yep. I don't read good. I read a lot. I love to read. Love to read. But I go too fast when it comes to certain things. And I see radicals are. Nope. It actually said rationals. Yes, ma'am. On number 2? Oh, okay. Gotcha. No, I'm not going to expect you to multiply that out. Okay, it's all right. And if for that problem, if that was your answer, and I think that was, which problem was that? Yeah, number 20, I would have been happy if you left your answer 6 to the 4th. Okay? I know. Sometimes, though I do believe that you can do 6 times 6 times 6, I'm not trying to purposefully mess up that. So if you can tell me that that's 6 to the 4th, we're okay. No. Just kidding. Which one? 23. Sure. 23, there's a lot of different ways that you can think about this. 2 to the 4th, 2 to the negative 1. It really depends upon how you see it. Some people go, ooh, negative. And so they move that immediately up to the top to make it 2 to the positive 1. And therefore, 2 to the 4th, 2 to the 1 is 2 to the 5th. Another way that you can think about this as 2 to the, and then the rule is this number minus that number. So 4 minus a negative 1 becomes 4 plus 1, which is 5. It's okay. Sometimes it looks so easy, it's hard. Yes, sir. 42, 32. Ooh, this one's a really good one because this is like that last problem we did in class. It still confused some folks. So 32, we have 3 to the 7th times 3 to the 9 to the 4th over the root of 27 to the 6th. Right away, I look at this and I go, 27 to the 6th? Are you freaking kidding me? There's got to be an easier way. Anybody remember what the easier way is for this? Yep. Base. Yes. That bottom number has to be the same. And what do they all have in common? 3. So 3 to the 7th, I'm not going to change. 9 is actually 3 squared. So 3 squared to the 4th is going to give me 3 to the 8th. 27 is 3 to the 3rd. And 3 to the 3rd to the 6th is 3 to the 18th. And then the square root of that. 3 to the 7 and 3 to the 8 gives me 3 to the 15th. Square root of 3 to the 18. 2 goes into 18 9 times. So my answer, my final answer, is 3 to the 4th. 3 to, yeah. Wow, Augsburger, you are doing great today, said nobody. Yes, because apparently 15 minus 9 is 4. Yeah, I wouldn't expect you to multiply that out. I'm not that cruel. Okay, last question. Okay, 47. I'm just going to pull it over so you guys can see this. 47, this was like that problem from the warm-up. You don't have any guy on the outside here. So I can really just think about this as dropping the parentheses. And if I drop the parentheses, 2 times 3 is 6. X to the 1/4 times x to the 1/4. We add those exponents, right? 1/4 plus 1/4 is? And what does 2/4 simplify to? So you could have either written x like this or x to the 1/2 power. And then y to the 1/3, y to the 2/3, that's just y. So I would have been fine with you writing 6x to the 1/2 y or 6y root x. Okay? All right, go ahead and clear your desks, please. Actually, no, pass forward your homework. When you talk about a negative number, a negative exponent, you just move it across the bar. So logs are used to deal with like really, really big numbers. They allow us to deal with really big numbers in a smaller form. It also allows us to figure out powers. If I wanted to say like 9 to what power equals 16. There is a power that you can take 9 to get that. It's just not an integer. So it allows us to kind of solve some interesting problems. The whole idea comes from the idea of inverses. How do we find an inverse? Does anybody remember? Any old inverse. How do I find an inverse? There's one step I need to do. Think about when we were trying to graph logs. We said graphing logs is not an easy thing. Flip the x and y. So in order to find an inverse, your first step is to switch the x and y. It means I would have x is 2 to the y. And then the inverse of that says, okay, now solve for the y. And if I want to get the y by itself with this, I would have that y is equal to the log base 2 of x. And I want to point out a few things here. That 2 is a little 2. That is a subnotation. It's like the opposite of an exponent. Exponents go up, these guys go down. And x is a full-size number. If we start with something that says a equals b to the c, is usually the way that they do it, the way I think about it is I say this number is equal to, so if I want to switch that over, we would say the power is equal to log base answer. That's how we flip-flop them. So the way I think about it is I say log of this, base that, equals that. It's kind of like this curvy thing. Log of this, base that, of this, equals that. And we deal with logs because sometimes it's easier to deal in exponential form. Sometimes it's easier to deal in logarithmic form. If you're given something in logarithmic form and it doesn't quite make sense to you, sometimes the best thing to do is convert it to exponential form. So I want you guys to write down problems 1 through 3. Okay, when we're doing this, the instructions said convert between exponential and logarithmic forms. Hopefully you understand from our rules of exponents that 5 to the negative 2 is in fact 1 over 25. Anybody have issues with that? So in order to rewrite this, I'm going to take the exponent is equal to log base of. And if you want to see that in words, what I just said, this is my exponent, log base of. That's where all those things come from. This is your exponent, base, and that's what the answer is. So how would I rewrite, bless you, stop it. How would I rewrite number 2 in logarithmic form? 3/2 is log base 4 of 8. How would I rewrite number 3? 3 equals log, and we typically say base 10 of 1,000, but you are actually correct because you just said log of 1,000. Right. If you look at your calculator, and we will be getting calculators towards the end, you are going to have this button right here. That log doesn't have a base. That button here is not going to work, for example, for a log base 5 or a log base 4. Just log, you see how it's got the 10 above it? That's talking about a log base 10. So if you do not see, I'm not going to mark you wrong if you put the 10 in there. I'm not going to mark you wrong. However, that is the same thing as saying just log of 1,000. If there is no base there, that number is 10. Kind of like if you think about a fraction. If you have no denominator, the denominator is 1. If you have no base, the base is 10. Okay? Go ahead and write down 4 through 6 for me. I get really excited with this stuff, guys, so please tell me if I'm going too fast. Because I'm like, ooh, this is cool. I enjoy this way too much. Okay, so before we started off with something in exponential form and we wrote it in log form. And the exponential form, for most of us, is going to make a lot of sense because I don't look at something and say, I happen to know that the log base 4 of 8 is 3 halves. Yep, some people can do that. Not one of them. But we need to be able to convert back and forth. So if I'm given it written in this way, how am I going to convert that back to an exponent? To an exponential form. Good. 2 is 8 to the 1/3 power. I kind of like to think of it as a swirl. Give me 1 second. I like to think about this in a swirly form. I like to think about it as 8 to the 1/3 equals 2. So if that helps you, you can think about it that way. How would I rewrite this, number 5? Right. And if you prefer to have 6 to the 0 power equals 1, I don't care. Does it make sense that 6 to the 0 power is 1? Anytime you see 1 in this position, the answer should be 0. Because anything to get 1 from any number, any base, is the 0 power. And again, I don't care if you write them this way or this way. I actually kind of prefer going this way because I look at it and I think 10 to the negative 1 equals 0.1. 10 to the negative 1 equals 0.1. Does that make sense? What is 10 to the negative 1? What does that negative do? It puts it as 1 over 10. Is 0.1 1 over 10? Yeah. But please don't write this as 1 over 10 because 1 over 10 was not in the original problem. 0.1 was. So they're not horrible, right? Today is not supposed to be a crazy, amazing, like, oh my God, what's going on day. We're just trying to get to know, like, hi, I'm an exponent. Hi, I'm a log. How do we play together? All right, go ahead and write down 7, 8, and 9. You'll see these instructions say find the exact value. That is the same thing as if I just told you to evaluate. Basically, you'll see those instructions when there are no equal signs in the problem. But I want to put an equal sign in that. I, again, don't think, I do happen to know what log base 7 of 1 over 49 is, but I don't expect you to do that yet. I can turn this into an equation and rewrite it as an exponent, and that might make our lives easier. So if I were to rewrite this as an exponent, what would you say? Seven to the x power is 1 over 49. And I don't care if you did 1 over 49 is 7 to the x power. It's the same thing, that lovely commutative property. Or the reflexive property. Commutative, that's commutative. And I want to solve this. In order to solve this, I need to be able to say both of these guys are the same thing. Can I rewrite 1 over 49? What is 1 over 49? It's 49 to the negative 1. Can I relate 49 back to 7? Yeah, because 41 over means my exponent is going to be negative, and 49 is 7 squared. If my bases match up, my exponents must match up as well. So the answer here is just -2. Log base 7 of 1 over 49 is -2. Yes? If you can look at it and know, great. Because it says just find the exact value. If you need to do the steps, do the steps. I want you guys to try number 8. We'll do number 9 together. You guys liking this a little bit? I'm seeing a lot of pleasant smiles, slight nods. Getting the hang of it. These things are a little bit more concrete. Yeah. It's okay. Let me guess. Did you prefer algebra or geometry? Yep, you're going to like this semester better. Then that's okay. It means you'll probably, there are some people that are very lucky and can get through it. I suck at memorizing. I did not like geometry. I loved algebra because I could piece things together and break it down and I'd be happy. All right, so what did you get for number 8? 6. Because this is like saying 2 to what power is 64? And can you rewrite 64 as a power of 2? That's 2 to the 6. So x is 6. So that means my answer is just 6. Now I wanted to do 9 with you guys because 9 is a little bit weird. If I rewrite that as an exponent, what would you have? 1/3 to the x power is 27. The reason why I think that's a little bit difficult, I don't really want to write 27 as a power of 1/3. That's weird. Is there some number that I can write them both as powers of? 3. So 1/3 is 3 to what power? And 27 is 3 to what power? 3 to the 3rd. So far, so good? And then what do I do with this number and this number? Multiply. So I have 3 to the negative x is 3 to the 3. So that means negative x is 3. What is my answer? Okay. So what we've got here is I multiplied these two together. If the bases match, the exponents must match as well. So I said I'm going to drop those numbers and just look at the exponents. If negative x equals positive 3, then x would be equal to negative 3. So far, so good? Okay. We're going to write down 10 and 11 for me. Whenever you have, whether it's a easy for me to say, logarithmic expression that you're trying to figure out, or an equation like this, the main thing comes down to, can you write the left and the right both in terms of the same base? So if I look at 10, what could I write the left and the right in so they have the same base? 2. 8 is 2 to what power? And 1/2 is 2 to the -1. What do I need to do with this 3 here and that 1 minus 2x? Multiply. And so if I multiplied, what would you have? And I have 2 to the -1. Since my bases are identical, that tells me the exponents have to be identical. So that means I'm just going to solve 3 minus 6x is negative 1. Well, that's just algebra. What do we do there? Subtract 3. And when I subtract 3, I'll have negative 6x equals negative 4. And then we're going to divide by negative 6 and get, there's your answer. Just solve an equation. Two-step equation there. Yay! So I want you all to try number 11 for me. Careful with your signs. Okay, what do we get? Beautiful, that makes me happy. So are we all right with that? All right, don't freak out. Okay, this is just a number. It looks scary. Don't write any of this down. Not yet, not till I tell you. You write down what I write down, okay? So, E is a number you might have seen on your calculator. It's in actually two different places. It's up here above the division sign, and it's over here above the ln. I don't worry about this one at all. I actually forget that that one's even there. And I would recommend that you do the same. The reason why is when we use this one, it's automatically going to force me to put a little power up there, a little exponent. And that's going to make things a lot, it saves a whole step for us on our calculator when we use it. But I want you to look, do you see how E is paired up with ln? Just like 10 is paired up with log. Log, if you see no number at the bottom, that means base 10. ln is a log with base E. And E itself is a number that it's really cool. It comes from all over the place in math. It's something that we see in exponential growth and decay when we're talking about continuous growth. It's something that we see in calculus. It's something that we see in statistics. It's something that's all over the place. E is what happens if I take this, 1 plus 1 over n, and I raise it to the nth power over and over and over again. So as my n gets bigger and bigger and bigger, we start to approach this little line right here. Now that number that we're approaching, it's like pi in that it's irrational. It has no ending and it does not repeat. So this number, just the few first digits are this. I am never going to expect you to memorize this. If you want to know anything, E is about 2.7. Okay? That's all, that's really a little bit ridiculous. You don't need anything more than that. You don't even need to know this quite yet. We are going to come back to this, and we're going to be using this a little bit later on as part of one of our formulas. What I need you to understand is the connection between E and ln. If I were to take e to the x equals y, and I were to write that in logarithmic form, I would say log base e of x, no, e of y, it's okay, equals x. The thing that you need to understand, that's all well and good. That's a correct statement. That is not simplified. It's like if you said 2 to the 2/4 power. Yes, that's correct, but it's not finished. Whenever you see log base e, that means ln. And if you see an ln, that means log base e. I don't know how to spell lonely X. Live in New York. Love New York. I don't know. Just making up stuff now. This is what I need you to understand. That E is a number we're going to be seeing a lot, has a lot of real-world applications. And log E is what we mean by ln. That's called the natural log. So let's talk about how that plays out. Go ahead for me and write down number 12 and 13. These problems are nice. They're kind of, wait, we're going to actually stop there because we just ran out of time. Bell rings now, right? So we will finish this during flex.